car travels once around a circular track of circumference 10 kilometers in 10 minutes. The average velocity, so if we're looking for velocity, we're looking at displacement divided by time. And the displacement, if it's gone once around a circular track, is 0. So 0 divided by whatever time is going to land up being 0 kilometers per hour. An object moves at uniform acceleration. So what you want here is constant acceleration, and that uniform acceleration is going to be that you are going to have a velocity time graph that would be a straight line, which means an equal up on the y and the x, and y and x. So for equal periods of time, you're going to land up with an equal increase in velocity. The velocity does need to increase all the time. So equal displacements are traversed in equal times. It's not constant acceleration. Equal increases in velocity over equal time intervals. Larger increases in equal time. It doesn't even tell you what that increases in. And the speed and the direction remain constant. No. So the correct answer over there is going to be B. An object is usually moving at uniform velocity now. So now we want constant velocity, and that means that if I had a displacement time graph, I would have a straight line. That means equal increases in displacement for equal increases in time. Let's see what happens there. Equal displacements are traversed in equal time intervals. So in other words, we're going to land up going 5 meters in the first second, 5 meters in the second second, 5 meters in the third second, and we land up with 5 meters per second. That seems reasonable. Equal increases in velocity. The velocity is not increasing. We know that the velocity has to be constant, so that's definitely wrong. The speed remains constant. Well, you can't just have the speed remaining constant. The direction also needs to remain constant for a constant velocity. And the displacement remains constant. That means you stood still. So that's definitely not true. So the correct answer is A. A lorry is driving on a straight road, and it moves in first gear from a position of rest to 9 meters per second, and then its speed increases. So let's go slowly over here, because the first question is calculate first gear. So we're going to go from 9 minus 0, and that took 3 seconds. So it's going to land up being 3 meters per second. Then they ask what happens in second gear. Second gear, it gets to 15. So it's 15 minus 9, which is 6. Again, that takes another 3 seconds. So that is going to be equal to 2 meters per second. And we've got the same story, and what is going to happen in top gear? Final velocity 24 minus initial velocity 15 is going to land up dividing this time by 10 seconds in the third gear. So that was going to be 9 divided by 10, which is 0,9 meters per second squared. Notice acceleration has a unit of meters per second squared. Now we've got this man who's walking along a rectangular field. He starts off, he goes 400 meters towards the north, and then he goes 300 meters towards the east. And it takes 10 minutes. What is his average speed? Remember, speed is distance divided by time. So I'm going to take the 700 meters, and I'm going to divide it by how many seconds? 10 times 60, which is 600 seconds. And I land up with 1,17 meters per second. Again, we're talking about speed, so look at the unit, it's meters per second. Now we're going to have the exact same situation, but we want to know his average velocity. Velocity means I'll need to determine displacement, so from start to finish, and if you put that into a Pythag triangle, you land up with 500 meters per second. Sorry, 500 meters. So the displacement is 500. I divide that by 600, and I land up this time with 0,83 meters per second. And what about direction? Because it's velocity, it has to have direction. So I'm going to be interested in that angle over there. We know this is north. We know this is east. So we can easily say that that would be on a bearing. I know my opposite side, and I know my adjacent side. Opposite and adjacent. So I'm going to use tan. Tan of alpha is equal to 300 divided by 400, and I punch into my calculator. Don't forget it's the inverse function of tan, and I will get 37 degrees. Now we've got the same story, except that the man is now going to come back home. So he goes his 400 north, he goes his 300 east, and then obviously to get back home he does 500. So now his total journey is 1,200 meters distance. His total displacement, on the other hand, is 0 meters. He has made absolutely no forward progress whatsoever when he gets back home. Now they want to know what is his average speed. It took him 20 minutes for the whole journey, so it's 20 times 60, which is 1,200 seconds. So it turns out to be exactly 1 meter per second. And on the very last one, you can't have a direction for no meters per second. So it's 0 divided by 1,200 seconds, and you get 0 meters per second.